in the peri-preschool experiment, there are only 123 students. In 1962 in the US, there were 25 million students between ages 0 and 5. So is 123 really a large enough sample size for us to conclude that these differences in means, these effects that we found in the previous modules, are real? Well, over here I've got a table from a paper by Anderson in 2008. And what he did is he did all the careful statistical inference that lets us determine whether our sample size was big enough or not. So what he did is he looked at the peri-preschool experiment and 2 other experiments, okay? ABC, ETP. I'm not going to worry about those for now, so just ignore those lines and just focus on the 2 lines labeled peri. He also looked at 2 different outcomes, IQ and high school graduate. I'm also just going to focus on this one line, high school graduate, which is very similar to the previous table we looked at of the effect of going to preschool on how much education you got later in life. So here it's whether you graduated from high school by age 18. Now, just like in the previous analysis, we're going to split it between female and male. So we're going to look at conditional average treatment effects for being female and conditional average treatment effects for being male. So there's a bunch of columns here. So let's just go through them one by one. Over here, we've got a column labeled CM. Okay, what does that mean? Well, if you go down to the footnote, fortunately, it tells you exactly what it means. CM refers to control mean. So that just means the average outcome among females in the control group. Okay, these are the people who didn't get preschool. So among the females who didn't get preschool, about 34.6% of them graduated from high school by age 18. Now this column here is labeled effect. Okay, now that is the difference between the treatment group mean and the control group mean. Okay, that's just the conditional average treatment effect. Okay, 49.4%. So that means that in the treatment group, the people who got preschool, about 49 plus 34, or about 84% of those females graduated from high school by age 18. So this is an enormous treatment effect, 49% increase in graduation, high school graduation rates by going to preschool for females. That's just huge, just huge. And that's a similar sized effect that we saw from the previous analysis, okay? And both that analysis and this are based on the same data, okay? So we should expect to see a similar outcome. Okay, now let's look at males. In this column, CM, we see that 66.7% of males who did not get preschool graduated from high school by age 18. Now let's look at the conditional average treatment effect. That's minus 6.1%. So that makes it look like going to preschool actually made it worse for males, that it lowered the amount of people who are graduating from high school. Okay? So the big question here is, do we have enough people in the sample size to conclude that these are true effects? And they're not just due to idiosyncratic differences between the people who happen to be in the experiment. Okay? So that's why we have to turn to the statistical inference. Now, the last time we saw statistical inference in these modules was when we were looking at the Oregon healthcare experiment. And there, the way we did it was we computed confidence intervals. And we asked, is 0 in this interval or not? Here, we're going to do a different approach, okay? And just to reassure you, there are only 2 approaches, confidence intervals and the second one called hypothesis tests. That's it. Those are the only things you'll really ever see for doing statistical inference. So here we're going to do a hypothesis test. And what that does is it says, is the effect we see due to just the random chance people that we got in the data, or is it really real? You know, if we did the experiment again, would we still see the same effect? You know, if we used a totally different sample of people instead of the kids we actually used. Okay? So that's what a hypothesis test does. Now, the way you're going to interpret the outcome of this test is by looking at something that we compute called a p-value. Okay? And I'm not going to get into how we're computing this because it does get kind of complicated and tricky, and it always tricks people up. But as far as interpretation goes, all you need to know is that if the p-value is less than 0.05, then we're going to conclude that it's a true effect. Okay? And the sample size was enough for us to extract this info from our data. If the p-value is larger than 0.05, then we're going to throw our hands up and say, we don't know. Maybe the sample size wasn't big enough. Maybe the effect doesn't actually exist. Okay? So that's the conclusion. So now let's look at p-values in this data. That's what is listed in these two columns here. Okay? This first column is called the naive p-value. So we're going to just ignore it because it's naive. Okay? Why would you want to do anything that's naive? Well, realistically, the reason we're ignoring it is because this paper is about doing all sorts of technical ways about how you actually compute these p-values and stuff like that. And as far as you're concerned, it really doesn't matter. Okay, so this they're putting here as a comparison for saying, oh, that old crappy approach that we don't like, and then this is their new approach that the authors came up with. Okay, so just ignore this, and let's look at this one. So it's called the FDRQ value. Again, just some technical name for the p-value. Okay, so here is the p-value for females, 0.001. Definitely less than 0.05. So we can conclude that this is a true treatment effect. That if we ran the experiment again, we would again find that females had a big effect of increasing the percentage that they graduate from high school by going to preschool. Okay, if we use a totally new set of kids, not the same kids in this data, we would still see this number. That's the conclusion. If we look over here at males, the p-value is 1, much bigger than 0.05, so we have to throw our hands up and say, we don't know. Maybe this is a true effect, but maybe it's just because of the particular people we had in the data. You know, we just don't know. So that's the only thing we can conclude from this. And since this is a small number, you might just say, well, probably there isn't an effect, okay? But the test is just going to tell us that we can't tell, okay? So that's the conclusion. When you do the careful analysis, the careful statistical inference, the same just raw comparisons of averages in the two control groups that we did before, those hold up. And it turns out these are actual true effects that we get from the data, okay? Going to preschool has a very big, strong effect on increasing high school graduation rates for females, but not for males. Okay, so that's the finding. Now, one final thing you might be worried about is that all of these students came from just one town, Ypsilanti, Michigan. Okay, and there might be something very special about that town that makes it not representative of the rest of the country. So even though we've done all the careful analysis and we've found true causal effects, it might be that those effects are specific to people who live in Ypsilanti, Michigan, or in Michigan specifically. So you might have to worry about whether we can extrapolate this finding to the rest of the country or to other time periods. So that's something that this data just can't answer, and you have to use something else to answer.